My name is Emily. I'm a fourth-year PhD student in the Azizi Lab in the Department of Ecology and Evolutionary Biology. Imagine Jurassic Park is real, and you get a visit. You're walking through a dense forest, and the flora and fauna is more beautiful than words. You hear a rustling in the bushes. Suddenly, a Tyrannosaurus Rex jumps out and starts to chase you. What would you do? You would run as fast as you can. But the terrain is really complex. You would need to run downhill. You'd have to land after jumping over logs and rocks. You'd maneuver around objects, and maybe you would even brake to hide. These are all decelerating movements. Stopping is crucial in the animal world. But decelerating events can cause muscle injury. After muscle injury, you feel sore and stiff. You lose your range of motion. And in this T-Rex chase, muscle damage would reduce your ability to escape. So what if I told you that it's possible to change your muscles so that you would reduce your likelihood of injury? In my PhD, I ask, how do different muscle properties predict injury? A muscle is an organ that is composed of these long, thin cells called fibers. These fibers produce force that move your joints to produce movement. Your biceps flexes your elbow, your quadriceps can extend your knee, but not all muscles are created equal. Muscles come in different sizes, shapes, and flavors, or fiber types. Most omnivores are familiar with different fiber types by knowing about different types of meat, white meat and dark meat. And these different flavors of meat are associated with different mechanical functions. White meat, like chicken, is usually associated with fast muscle, while dark meat, like duck, is usually associated with endurance muscle. And humans have both fiber types in the same muscle usually, like pork. And it's also possible to change between our muscles from more white to more dark depending on your age, health, and exercise program. Muscle properties can also differ in their fiber arrangements. So some fibers are arranged in parallel, and some fibers are arranged at an angle, like tufts on a feather. Muscle physiologists have described how different properties produce different amounts of force. However, we're missing half the story. Animals that produce force to accelerate also need to decelerate or dissipate force. And to do this, muscles must lengthen while active in order to dissipate mechanical energy. And it's this active lengthening or a stretch that might pull the fibers apart and cause damage. So, how do different muscle properties incur damage? To answer this question, we need to do some basic research. In the laboratory, I can recreate a big landing. I do this with an anesthetized rat and a lever arm controlled by a computer. The lever arm can measure force and apply length changes. First, I measure how much force a muscle can produce. Then I actively lengthen that muscle or stretch it. And then I measure how much force that muscle can produce after I recreate a landing. I assume that the amount of force lost during these trials is a measurement of injury. Muscles that lose less force are less injured. And what I've found is that muscles that have fibers arranged at an angle are less likely to get injured. In the real world, we aren't chased by dinosaurs. But we do have major sports events, we have military combat, and muscle disease. Therefore, it's still important to understand how different muscle properties predict injury. We can use this knowledge for clinicians to identify people at risk for muscle injury, and we can also use this knowledge to inspire better prosthetics for complicated terrains. Muscle injury is also really good sometimes. Muscle damage stimulates muscles to get bigger. It also improves the electrical signals we send from our brain to our muscles. And together, these effects can improve our strength and stability. Therefore, in 20 years, I hope that I could scan and biopsy someone's muscle and use my research to tell them how far they would have to jump or how much weight they would have to squat before they incur injury. And this would be good for both people who want to cause or avoid injury. I'm really excited about the knowledge basic research can give us, and I hope you are too. Thank you.